Good day. Today's lesson in Game Programming 1 is about saving and loading scenes. After this lesson, you will be able to save and load scenes in Unity. Know and learn basic scripting. Create a basic movement script using C#. From time to time, it is best to save your progress so that you won't lose anything when something unexpectedly wrong happens. Saving and loading in Unity also happens in scenes, so hitting Ctrl+S will only save the scene but not the Unity project. Saving a scene will store the file in the Scenes folder found under the project view. It will automatically create one if the folder does not exist yet. To create scenes, just right-click in the Assets folder and hover on Create, then select the Scene option. Give it a name and hit Enter. Double-clicking a scene will load them in the editor, and you can see it update in the hierarchy view. You will receive a save prompt when loading another scene while the active scene has unsaved changes. Importing still images and have them do nothing is nonsense. That's why scripting is imperative to making games in Unity, as it can make or break a good game. Scripting is the process of writing blocks of code that perform various functions. They are attached to game objects and appear like components in Unity's inspector view. Scripting in Unity typically uses the Unity version of JavaScript, known as UnityScript. However, it is best to use C# nowadays since UnityScript started its deprecation phase since 2018. There are many ways to create a script in Unity. One of the easiest methods is to click the Assets tab at the top left corner of Unity Editor and hover on Create, then select C# script. It is also advisable to create a scripts folder under the Assets folder of your project to keep things organized. Generally, scripts should be named according to their function but leave the name as it is for now. Double-click the script to open it up. As you can see from the image, lines 1 to 3 are the libraries that are imported in the script by default. Line 3 is what we will be using the most for this course. Moreover, line 5 is where creating the program behavior of game objects begin to happen. Lines 8 and 14 are the most common functions that are used in programming games in Unity. All of these will be discussed in the next slide. The MonoBehavior library contains various classes and methods that are very useful when scripting in Unity. The start method runs only once and is generally used for initialization. The update method runs every frame at 60 frames per second after the start method is called. The update method will be called 60 times per second unless otherwise modified. For this lesson, we will create a basic movement script that allows a game object to move in the 4 directions according to the user's input. We will manipulate the transform component of the game object, and what's great about this is that all components can show up as variables in scripting, meaning that we can modify their properties through code. To create the movement script, we must first create a new script asset and name it as a movement. Double-click the file to open it up. Inside the movement script, we will create a public variable named speed. One of the advantages of public variables is that its value can be modified through the inspector view where the script is attached to. The data type is in float so that it can accept decimal values. Now, saving the script without touching the other methods, it should compile in Unity. Now, Drag and drop the movement script from the assets in the project view into the game object in the hierarchy view. Afterwards, you should see the following image. As you can see, the movement script is added to the game object like a component, and the public variable speed is modifiable in the inspector view. We will now make use of the update method instead of start since we declared the speed variable to be public. Now, in order to move the game object, we will utilize the update method. Check first for user input, read and store the directions in a variable, then change the game object's transform component based on its speed and direction. Let's discuss the code briefly. Inside the update method, we are storing the horizontal and vertical input inside variables h and v respectively. This is made possible by utilizing the input class of Unity. These will be the user input and they will change when the player presses a directional key on the keyboard. Every time the update method is called, a vector2 will be created which will modify the transform component of the game object that this script is attached to. The values change according to the current position plus the user input multiplied by the speed value, which is the public variable discussed earlier. Save this script and head back to Unity. Unity will automatically update all scripts once it compiles successfully, so you don't have to reattach the script again and again. From the inspector view, change the speed variable of the object to somewhere around 0.5 so the player can start to move, but not too fast. You can modify this value however you see fit. Make sure that you select the game object where the script is attached to so you can see and modify the movement script from the inspector view. Hit play and see your first small game in action. If you notice, pressing the arrow keys will make the object move around the scene. To stop the game, simply press the play button again. You can adjust the speed while in play mode, but after exiting, it will revert back to the value before hitting play. Here are the references for this lesson. Thank you for watching.